Okay. All right. So here we are going to learn how to do the graphing. Solve the systems of equation by graphing, interpret the solution. Maha works at a car dealership and sells cars while Noof, her co-worker, sells trucks. So Maha and Noof work at the same place, but Maha sells cars and Noof sells trucks. This month, Noof and Maha sold 80 vehicles. So I said M will represent Maha and N will represent Noof. So Maha and Noof, they sold 80 vehicles. That means vehicles means different types of cars. Yes. Yes. So in here there is cars and trucks. That's what I'm trying to say. That's what vehicles means. Okay. Maha makes 100 per car, so 100 goes with Maha, 100 M. And Noof makes 200, so 200 goes with Noof, 200 N per truck. This month they made, that means whatever Maha made and whatever Noof made together. So that's how I knew I needed to add. They made 11,000 dirham. How many cars did Maha sell? And how many trucks did Noof sell? That's the question we need to answer. Write and solve and interpret. Write, solve, interpret the solution of a systems of equation that represents this scenario. So we have written. When you're writing, you define the variable and you write your equation. So that's the answer to this part. Now we want to do the solving. So I have two equations. I have M plus N equals 80. So I want to graph. This is my equation 1. I'm going to label that equation 1. For me to graph, I need a table. Okay. I need a table. So we're going to put M here and N here. Okay. So number of trucks, because it's N for Noof, we label number of trucks. And then M will be here, number of cars. M. N. Okay. All right. My equation is in standard form. My y is n. So I need to move this here. So that becomes minus m minus m. My new equation, this goes away. So that will be n. N is 80 minus m. See? 80 minus m. Okay? Or let me do it over here. So you have m plus n equals 80. This is my x, this is my y. How do I know? Because I did that on my graph. So I want y by itself. I will subtract m on both sides. Remember your bridge. So this will go away. I will be left with n equals 80 minus m, or negative m plus 80. It doesn't matter, whichever one I want. I'm going to do 80 minus m. When m is 0, so I have 80 minus 0. Remember your m is in bracket, okay? 80 minus 0 is 80. So that's my first point. Then I do my second point. I can do when m is, okay, it doesn't matter, you choose whatever number you want. Let's choose m is 5. When m is 5, 80 minus 5 is 75. So my first point is 0,80 and my second point is 5,75. Now I'm going to label my graph. Before I label my graph, I need to look at my, yes, let's do my second equation where I don't have space. I'm going to do it, I need space. I'm going to do it at the back of this paper. Okay. So when I finish drawing, I'll put the work over here. So this is 100M plus 200N equals to 11,000. I want N by itself, so I need to move 100M. 100M goes, okay, my bridge is here. This house goes away. This house becomes, what is 1100 minus, that should be, okay, subtract it on the calculator. That's 0, that's 0, that is 9. No. Don't tell me I forgot how to subtract 109. Yes, let's confirm. What am I doing? I cannot subtract these two. Why did I put them in? See? This is why I say you have to pay attention to what you're doing. Okay. 100M plus 200N equals to 11,000. Okay? All right. I need to move this to this side. Here is my bridge. So minus 100M minus 100M. This house, because they belong together, they have the same variable. This cannot be housed because they don't have the same letter. All right. So then I have 200N equals negative 100M plus 11,000. Now I have to divide all my terms with 200. Okay, so this goes away because it becomes 1. So this is N equals, this becomes, I will use a decimal, negative 0.5M plus this and this goes, this and this goes. 2 goes into 110. How many times? 55 times. So let's check. 110 divide 2, 55 times. Okay, so 55 times. So here is my second equation. Okay, so I'm going to use that equation to make a table. See, I need space. I'm going to do it over here. So I have M, and then my work is in the center, and then N. And what is my equation? Negative 0.5 M plus 55. So when M is 0, negative 0.5 bracket 0 plus 55, that gives me 55. Okay, and then I can use, if I use an odd number, I'll get a decimal. So I'm going to use an even number. So let me use 2. If I use 2, that will be minus 1, yes? Yes, and that will be 54. Okay, so that will be negative 0.5 bracket 2 plus 55. So if I put it in my calculator, I should get 54. Negative 0.5 multiply by 2 plus 55 is equals to 54. Is equals to 54. I wanted a number that ends with 5. I want a number that ends with 5. I should try make this a 0. Maybe 4 here. 4 here, and then, so let's see. Change this to 4. I get 53. Change this to 6. I get 52. Change this to 8. I get 51. Change this to 10. So negative 0.5 times 10. Plus 55 gives me 50. Okay, instead of using, because I wanted a number that ends with 5. So I'm going to choose 50 here. So this will be 10. I want M to be 10, okay? Just to make life easier. All right, so if I put 10 on here, I will get that, you see? So there. So my 2 points are 0 with 55 and 10 with 50. Then now we plot. You will see why I said I was choosing numbers that are friends of 5. Because we want to use our graph efficiently. So I need a 10 on the x-axis and a 5. So I will say every 2 boxes is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see, I skipped 2 boxes, I put a number. 2 boxes, I put a number. Make sure 15, 16, 17. And don't forget to label. You should have a title on your x-axis. You should have a title on your y-axis. So instead of us writing y, but anyway, you should have written N there and M here. That's all right. Okay. Now, as you notice, the numbers on my y are all multiples of 5. So that is why I want to make sure I go by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, maybe I should skip 2, but it doesn't matter. 65, 70, 75, 80, 85. Okay? My graph is so squished. I don't know. Okay, doesn't matter anyway. All right, so now I plot 0, 80. 0, 80 is here. And then 575. 575 is a little bit low below 70, right? Where is 75 here? So 75 and 5, right there. Yes, because 75 is one box from 80. Like that. I should have made my numbers a little bit wider. Okay. Alright, then I take my ruler and I join. There. So that is this equation. M plus N is 80. M plus N equals 80. I write it on the line. Okay? Now I want to do the second equation. So I'm going to use my second table. 0 and 55. 0 and 55 is right here. And then 10 and 50. 10 and 50. If this is 55, see? This is 55, I want 10 and 50. One box down. Okay. And then with this, I need to draw a straight line. So as you can see, I can't tell from my graph this graph is not helping me to know the solution. But if I continued, these lines will meet somewhere. Okay? So that we know the solution. But we can find the solution a different way. But I just wanted to show you how to do that. Okay? So I have labeled my variables, and this is my equations. I have tabled each equation. Each equation has to be in a table by its own. So you have to change your table to slope-intercept form. Sorry, your equation. Change all your equations to slope-intercept form. And then make the table. And then get 2 points and then plot the points on your graph. So here you see we can't do this because this graph has to meet somewhere outside. So maybe this was not a very good question for graphing. But it can be solved another way. Don't worry. We'll do other graphs. Alright, before we move on, I wanted to show you the question I told you for Salama and Alia. This question here. Salama and Alia drove 750 miles in 12 hours. Like that. Salama drove the first part of the trip at 65 miles per hour. And Alia drove the remaining part of the trip at 55 miles per hour. Write the systems of equation. So I know Salama and Alia. First of all, I said S will represent Salama, A will represent Alia. So Salama and Alia took 12 hours. And then 65 was for Salama because it said over there 65 miles per hour. And Alia was 55, so all of them drove 750. So there is your answer. And you can see I've boxed all my answers. Box all your answers. So this is your solution here, and this is your solution there. All right, let's continue with the graphing. Let's do this. This will be a very good example to see the solution. All right, so I don't want to dull my pencil. So this is already in slope-intercept form. So you just do this, draw your table. This is x, this is y, this is -2 bracket x minus 3. So x is 0, so you do -2, 0 minus 3, you have -3. Okay? So your first point is 0, -3. Now let us do this one. Oh, we need another point. So that's only 1 point. So which one do we choose? We can choose a positive number. +1. When x is 1, negative 2, 1, minus 3. Negative 2 times 1 is negative 2. This is negative 5. So 1 comma negative 5. So there. Then you do the next graph. The next equation, negative 5 plus y equals to 2x. It is in standard form. I want it to be in y-intercept form, slope-intercept form. So plus 5 plus 5. This goes away. So you have y equals to 2x plus 5. I'm going to do this. 2 bracket x plus 5 x and y. When x is 0, y is 5. So 0, comma 5. Okay. We can do when x is negative 1. 2 bracket negative 1 plus 5. Negative 2 plus 5 is 3. When x is negative 1, y is 3. Okay, now we can plot. So 0, negative 3 for the first one. 0, negative 3. 1, negative 5. Okay, where is my ruler? I take my ruler and I join my points. Okay. So you can say this is equation 1 and this is equation 2. So you can label that equation 1. Now we want to do for equation 2. When x is 0, y is 5. When x is negative 1, y is 3. And then you take your ruler and you join your points. Okay? Okay. And that is equation 2. And then this is your solution right here. This point is the solution. And you say solution. And you circle it. Okay? So you see mine is in the middle of the box, so I don't know exactly what is my x. Maybe negative 2.1. And my y, maybe 0.9 or 0.8. I don't know exactly. So then, state the solution. Mine is not very clear, so I'm just going to write, what is this? Maybe negative 2.1. So, negative 2.1, comma, and then maybe 0.9. Or 0.9 maybe. 0.9. So there is my solution. You see? I have stated my solution. And then justify your reasoning. I have one solution. Because my lines are intersecting at negative 2.1, comma 0.9, like that. Okay? All right, let's see another example. So, equation 1 equation 2. So it doesn't matter which one you start with. It really doesn't matter. So I want to make equation 1 in slope-intercept form. Y minus 3x equals negative 4 plus 3x plus 3x. Y equals to 3x minus 4. Okay? Also, another thing I wanted to show you. What did I want to show you before I continue? I knew I was going to have one solution. Why? Because my slopes are different. Do you see that? Because my slope here is negative 2 and my slope is 2. So I knew my lines have to intersect. Okay? So that's how I know. How I knew I was going to have one solution. So even before you start drawing, by looking at the equation, you should know whether you have one solution or no solution, or infinitely many solutions. So here is my first equation. Now, if I look at this equation and this equation, I will know I don't have a solution. Why? Because the slopes are the same. So I know my lines will not meet. So let me draw my table. This is x. This is 3 bracket x minus 4. And this is y. X is 0. 3 bracket 0 minus 4 is negative 4. 0 comma negative 4 is my first point. Then I'm going to do by 1. When x is 1, 3 bracket 1 minus 4 should be negative 1. When x is 1, y is negative 1. Okay? For x, you choose any number you want on the x line. That's where these numbers are coming from. I choose whatever number I want. From the x line, I can do that. And I only need 2 points. I don't need more than that. So this is equation 1. So every table I label. Now I want to do equation 2 so that I don't make a mistake. X, 3x minus 2, y. X is 0, 3, 0, minus 2, negative 2. When x is 0, y will be negative 2. So 0 goes with negative 2. Okay? What do I want to do? I can do 1. When x is 1, 3, 1 minus 2 is 1. So this is 1, comma 1. All right. Then I take my pencil. All right. My first one is 0, negative 4. 0, negative 4. And 1, negative 1. Once I put my first 2 points, I draw the line immediately because I don't want to confuse. Okay? Then I draw the other one, 0, negative 2, and 1, 1. Okay? And as you can see, these lines are parallel. They will never meet. Okay? So, state the solution. No solution. Okay? Justify your reason. There is no solution because my lines are parallel. And they will never intersect. Okay, so I just remind you, intersecting means solution. If they don't intersect, then there is no solution. That's why I wrote they will never intersect. So this is no solution because your lines are parallel. And then let's see if you drew them nicely. Yes. All right. You will draw this one. So now here, this one is already in. Oh no, that one is not in slope. Even this one is not yet in slope intercept form. Why? Because we have a bracket. So that means I have to do distributive property. So let's do the first one. Y minus 2x equals to negative 4. So bring this to this side. Plus 2x plus 2x. This goes away. Y equals to 2x minus 4. Then x, y, and then 2 bracket x minus 4. When x is 0, 2 bracket 0 minus 4 is negative 4. So that's 0 comma negative 4. Then you can do when x is 2. 2 bracket 2 minus 4. 2 times 2 is 4. 4 minus 4 is 0. So that would be when x is 2, y is 0. Okay? Now let's do this one with the bracket. Y equals negative 2x plus 4. I don't see a number outside my bracket. I'll write 1. Y equals to negative 1, 2x plus 4. Negative 1 goes with 2x. Negative 1 goes with 4. I will multiply. Whenever we are doing distributive property, we are multiplying. Y equals to negative 2x plus, no, minus 4. This is minus 4. Now, do you see? I don't need to do a table because this equation is the same as that equation. Did I write the correct equation? No, there's supposed to be a negative here. Sorry about that. Okay. So now, negative 1 times negative 2, y equals to 2x. Negative 1 times positive 4, y equals to negative. Negative 1 times positive 4 equals to negative 4. Now, you see this equation is the same as this equation. Okay? Because they are the same, I don't need to do another table. I just do one table, one. Because I noticed my equations are the same. And because I'm going to do one table, it means I only going to have one line. So, infinitely, what is it saying? Infinitely many solutions. Infinitely many solutions. Justify your reason because I have an infinite number of solutions because I have only one line on my graph. Okay? So, you can label that 0, negative 4, and 2, 0. And then with your ruler, you draw the line. Why did I use a pen? Don't use a pen, use a pencil. Use a pencil. Don't use a pen. And there. You join your dots with a ruler. You join your points with a ruler. And there is your answer. So you have graphed from the table. It's the table that helps you to graph. From the table, you can tell how many solutions. But even by looking at the equation, you should be able to tell how many solutions, okay? Because the slope and the y-intercept are the same, then you have infinitely many solutions. All right, the last one. Here now, they didn't give you equations. They gave you points. They didn't tell you to write them, so I'm not going to write the equation because the question did not say that. So let's read. A system of equation consists of two lines. One line passes through 2, 3, and 0, 5. The other line passes through 1, 1, and 0, negative 1. Determine if the system has no solution, one solution, or infinite number of solutions. So I'm going to graph. My first line is this one. 2, 3. 2, 3. Right there. My second line is 0, 5. My second point is 0, 5. Okay? So with that, I take my ruler. And I join a straight line. And then I write this is for equation 1. Because this makes equation 1. Okay? Equation 1. Because they said one line passes through that. The other passes through this. So I have 1, 1. 1, 1 is here. And the other one is 0, negative 1 right here. Okay? So let me put my phone down. After I join my points. So then you will see. Okay? And there. So now I have one solution. How do I know? Here is my solution. Okay? A solution is a point that is in both lines. Remember, this is equation 2. So a solution is a point that is in equation 1 and it is also in equation 2. So this point is in both lines, okay? So we have graphed. Take the solution. We have one solution. One solution. So since this is easy because it's on the line, 2, 3. 2, 3. Then justify your reasoning. We have one solution because the graph crosses at 2, 3. There. You have said the graph crosses or the graph intersects. The graphs intersects at 2, 3. Okay? All right. So complete your examples and then we'll talk about them on Sunday.